Okay, 5.4. First problem we're going to do is 59. That was the first one that was left with a question mark. It says find a so that f of x equals log base a of x, and it contains the point 2, 2. So y is 2 when x is 2. So to what power do I take a to get 2? And the answer is 2. So if I change this back to a power equation, this says a to the 2 is 2. Now to get rid of the 2 on the a, to find out what a is, I'd have to take the square root of both sides. Let's get rid of this, and so a would have to be plus or minus the square root of 2, but the base can never be negative, so a equals square root of 2. Now let's do 64. 64 says, where is that here? F of x is 1/3 to the x. F inverse of x is log base 1/3 of x. And we're graph these on the same axis. So 1/3 to the 0 is 1. 1/3 to the 1 is 1/3. 1/3 to the 2 would be 1/9. 1/3 to the -1 would be 3, because the minus would take the reciprocal. And so there's what F looks like. Now let's do F inverse. To what power do I take 1/3 to get, let's say, 1? Well, 1/3 to the 0 is 1. So, log of 1/3 of 1 is 0. So if x is 1, it's 0. I'll put x's on the points here, which is just the opposite of this one. This is 0, 1, so this is 1, 0. This was 1 1/3, so the log would be 1/3 1. This was 2 1/9 for the original, so the inverse would be 1/9 2. This was -1 3, so the other would be 3 -1. No, right there. And so the graph would look like this. And if you notice, that's a mirror image of the original being here. Now a mirror image of that over the y equal x line. Okay, so that means inverse. And that's what happens with inverses. Let's do 67. 67 says we have a graph of a log that looks like this. Goes through -1 and it goes up like this. Now what does a log normally look like? So, and these are all in base 3, so y equals log base 3 of x. So this is kind of the reverse of let's see, 3 to the y equals x. That's what this means. So to graph this, it'd be easier to say, let's find a y and figure out what the x is. So if y is 0, x is 1. If y is 1, x is 3. If y is 2, 3 to the 2 is 9. We'd be out at 9, way out there. And if y is minus 1, that would be 3 to the minus 1 is 1/3. And so this is what y equals log base 3 of x looks like. Now this one looks like this one flipped over so that it goes this way, and then flipped over the y-axis to go this way. So that would mean that we have to flip it both over the x and the y. And so to flip it over the x, we'd put a negative on the x, and to flip it over the y, to flip it over the y, we'd put a negative on the x, and to flip it over the x, we'd put a negative in front. So we get y is the negative log base 3 of negative x. And that happens to be, which one? D. So this is a graph of D. Okay, next one is 87. Now on 87, where we have f of x equals 2 to the x over 3 plus 4. And we're supposed to find the domain of f. Well, we can have anything for the power, so domain is the reals. B, graph it. So if I put in 0, 2 to the 0 is 0, plus 4 is 4. 1, 2, 3. 2 to the 0 is 1, plus 4 is 5. This exponential is raised up to up here with the x-axis here, because it's up plus 4. And so it's going to go something like this, except that it's a third of x, so it's 3 times as wide. Now normally if you go over 1, you'd have 2 to the 1, but it's only to the 1/3. If you go out to 3, you'd have 2 to the 3 over 3, which is 1. 2 to the 1 is 2, plus 4 is 6. So it's up 1 by 3, up to 6. So normally it would have been at 1, but since it's divided by 3, I have to go to 3 to get it up 1. And so it's going to go like that and very gradually down. That's what this looks like. And you can use any x for it. The range will be above 4. Let's see, do they ask you for that? Determine the range and any asymptotes. So the range would be C, the range is goes from 4 to infinity, and there's an asymptote of horizontal asymptote of y equal 4. Okay, and D, find the inverse. So now we got to switch the y and the x, so we'll have x equals 2 to the y over 3 plus 4. Now we got to solve for the y. So we want to get it down to just a power equation, so we'll subtract 4. So we'll have x minus 4 equals 2 to the y over 3. Now we have a power equation. We'll write it as a log because we're trying to solve for the power. So to what power do we take 2, 2's the base, to get x minus 4? And that's what this power, y over 3, is. If you multiply both sides by 3, we get 3 log base 2 of x minus 4 equals y, which is then the inverse of f. Okay? And E, find the domain and range of f. Well, it's going to be symmetric with this, so if that's the asymptote this way, it would be a vertical asymptote here. It would get closer to it and go up like this. So the domain would be for 4 and greater. So greater than 4, not 4. And the range would be all real numbers, because it'll go from negative infinity on up to positive infinity. That was a tricky one. I can understand why some of you had that one left. And now let's do the last one in this section. No, second to last. 117. Says graph this piecewise defined function. F of x is negative ln x from 0, not equal, just less than x less than 1. And when x is greater than or equal to 1, we want to draw ln x. So, what's ln x look like? Well, it's the inverse of e to the x, which looks like this, going through 1, and 1 it's at e, or 2.7. So the inverse would go through 1 over here and go this way. Pen's running out of ink. And so if we're going to draw ln x for greater than 1, we would draw this. And then for between 0 and 1, which was this part, we're going to draw the negative of that, which would be, the ln would have normally gone down here. Let's see here. Yeah, it would have gone down here to match this, but we're going to draw the negative of that, so it's going to go up like this. So you're going to get a curve that comes down like this, like it's going to do a log this way, but then it's going to go like that. So that's what 117 would look like. And now 120. 120 says, oh, this is the diversity index. And I did this one in class. So I'm not going to do 120. All right.